Hi, so this is a lesson on radian measure, a continuation of what the most recent lesson was, but in this case we're going to go after specific questions. So it's kind of a oddball assortment of problems you're going to run into. So to begin with, I'm going to evaluate the following ratios correct to 4 decimal places. And we did these before, way back when we would do something like find the sine of 25 degrees or whatever like that. So they are calculator questions. But in this case, you've got cos of 3 pi over 4 rads. And we have a choice. And this is a choice that's going to play itself out over and over in this unit. And the one method that many of you will use, probably overuse, is to convert this into degrees and do the calculation in degrees. Now there is a time for that, because there are times when the calculator cannot work out an exact value for it. So you will see that this does become useful at some point. But and I'm going to go through it, but I'm going to gradually more and more stick with straight radian measure and avoid the conversion, if only because it saves time. But anyhow, for practice, 3 pi over 4 into degrees, you can multiply by 180 degrees over pi, which is the conversion formula, or you can do what we just did previously, which is to view that circle and recognize that it is equal to 135 degrees. And I'm not going to do the calculation, but make sure that you get that number. This question then is the cosine of 135. And I just drive it into my calculator. In doing so, I will get negative 0.7071 with the round. So when you're asked to find a ratio, that's what you're doing. Cos 135 means if you have a 135 degree angle, what is the ratio of side adjacent to hypotenuse? So always be aware of whether you're looking for an angle or whether you're looking for a ratio. In this case, the angle is given, we want the ratio. Let's do another one. Or excuse me, let's do the other method first. So what you can do, and what you have to start using now, is the rad mode on your calculator. So you press mode, and this time you select radian, so it's the third line on that menu, and make sure you press enter. And now we're in rads. Always be aware of what mode you are in for this unit, because it does make a difference. And if you're in rad mode, all you need to do is go cosine 3 pi divided by 4. Close up those brackets, and then you'll get the same answer. So that was more direct by staying in rad mode, and the choice is yours. There will be a time when it is advisable to go into degrees. Normally not, though, and this is quicker to stay in rads. Then let's try another one. Here we have the cosecant of, or we want the cosecant of 5.1 rads. So I note first off that cosecant is equal to 1 over sine, and I am going to use my calculator on this one because 5.1 is kind of a nasty number. Like that 3 pi over 4, although you may have had to use the conversion formula for it, 3 pi over 4 is what we call a special angle. It's a 45 degree reference angle in quadrant 2, and you see it on that circle that we drew earlier, so it keeps coming back at us. So most of you would not have to do a conversion on it. You'll just know how many degrees it is. 5.1 rads, not so. So cosecant theta is equal to 1 over sine theta, and therefore this, as long as I'm in rad mode, I can go 1 divided by sine of 5.1, and I'm going to get negative 1.0801, again to 4 decimal places. So the real lesson is to make sure you know what mode you're in and when you want to convert your calculator to degrees and when you want to stay in rads. Normally quicker to stay in rads. Now I'm going to do the reverse. Here we are asked to find all values of theta in the domain 0 to 2 pi. Now, we did these questions before, but we were in degree mode. And the fact that this domain is given to us with pi in it, 2 pi, tells me that we are supposed to answer this in radian measure. That's always the tip-off. And we are now looking for angles. So the question is going to be the opposite of what we saw before. These questions you're going to be seeing are very, very important. You saw some before with degrees. These are even more common in rads. If you can master these, even as they get more complicated, you will do fine on the exam. So question number 1 is tan theta is equal to -1 over square root 3. And I mentioned last time, a couple lessons ago, that when you're solving questions that are about looking for the angles, and that is finding all values of theta, we have kind of a 3-step process. And I always note what quadrants we're in first before I do anything else. Since tan is negative, thinking of the cast rule or just simple reasoning power, I know that we must be in quadrants 2 and 4. That's where tan is negative. They're all positive in 1, only tan is positive in 3. So I know I'm in quadrants 2 and 4, and I know I'm going to get 2 answers for this. And then I go after my reference angle. And for this one, I'm going to be in degree mode. Not necessary, but just to show, I'm going to show both methods for it. So I'm putting my calculator back in degree mode. And then, to find the reference angle, anytime you're looking for an angle, remember it's second function of that ratio, second tan, and then I just open up a bracket, 1 divided by the square root of 3. Do not key the negative in for the reference angle. Remember, the negative was there to tell us where we are. With respect to the reference angle, we don't have to do that. And it'll just mess us up. And I will get a reference angle of 30 degrees, so make sure that that's what you are getting as well. And then the method continues by taking that 30-degree reference angle and putting it in quadrants 2 and 4. Remember, the reference angle is always off the x-axis. So we have a 30-degree angle in quadrant 2 as well as a 30-degree angle in quadrant 4. And now we just find out the rotation angle in both cases. And I'm not doing a lot of work for this one, but if we have a 30-degree angle in quadrant 2, it means the rotation angle must be 150 degrees. That is 180 minus 30. And the 330, we took the 360 and subtracted 30. So always off the x-axis. And we're not done yet, because this one did want the answer in rads. So we have to convert it into radian measure. So if you do your calculation in degrees, it always means you're throwing in extra steps. And that's why you're encouraged to do them directly in rads. So the question that we're doing now, when we go back to questions like this in the future or review them, most of you will be very quick. Most of you won't bother putting it into degree mode. So 150 degrees is equal to 5 pi over 6 rads. So you can either do that by multiplying by pi over 180 and reducing, or you could do it simply by looking at that circle and remembering it. 330 is 11 pi over 6 rads. So we've got 2 answers right there. But if the question gives you the domain in rads, you need to give your answer in rads as well. Let's continue with these. This is sort of an odd-looking question. Cosecant theta plus 4 is equal to 0. And here, we are supposed to answer it to the nearest 1/100th of a rad. Now the domain between 0 and 2 pi is actually giving us a domain that's in as exact values, meaning that we're not doing any rounding. 3 pi over 4 or 5 pi over 6 or whatever like that, those ones are all exact values. Here we're going to decimalize it. I need to solve this equation. It wasn't even given to us as a ratio. Cosecant theta is equal to -4. The 4 has to be taken over. And very important, you do not have a cosecant key in your calculator, So you need to write it as sine. So the reciprocal of negative 4 over 1 is negative 1 over 4. So sine theta is equal to negative 1 over 4, and then we do the same thing we did previously. We identify that we are in quadrants 3 and 4. I know it says 2 and 3, but that should be 3 and 4. I'll fix that right afterwards. There we go. So quadrants 3 and 4. And we have a reference angle of 14.478. Now, I is also this time kept my calculator in degrees. So make sure you got that second function sine 1 divided by 4. Do not key in the negative. And then if you take a look at your grid, we'll be in quadrants 3 and 4 down below. And a reference angle always off the x. So to get the quadrant 3 answer, we go 180 degrees plus 14.478, which is 194.478. I've got 3 decimals going. I did that because our answer has to be rounded to 2 decimals ultimately, and I'm keeping one extra one there for the round. And then the next one would be 360 minus 14.478. And that would give us 345.522. And we're not done, because we have to convert it to rads. So 194.478 degrees, if you were to multiply that by pi over 180, and because we're rounding and decimalizing, we multiply that pi right in. So it's 194.478 times your pi key divided by 180, and that will give you 3.39 rads. So you multiply it in. Do not keep the pi alive. Then do the same thing. 345.522 we multiply by pi over 180, and when we decimalize it, we'll get 6.03 rads. Now there was quite a bit of work with that, and if this question showed up on an exam, I think most of you would have kept it in rads. And you could have done it. You just have to be very, and we will do, as the questions get more complicated, I will be doing that. But we would have had to have been careful in taking the reference angle and then making sure that we added on to pi or subtracted from 2 pi. So for now, I think it's a reasonable way to do it with the degrees, just to practice the conversions, but we will be moving away from that as we go through, as you get more and more comfortable. Now I'm going to change gears and give a different sort of question, kind of just an oddball conversion one, so it's got nothing to do with, you know, finding angles or anything like that. This is an arc length problem, like we first started doing at the beginning of this section. And here's a diagram, a circle with a 70 degree interior angle and a radius of 4.2 centimeters. The arc length is not indicated with an A, but it would be the arc that is cut off by that angle. And we want to find out what that arc length is to the nearest tenth of a centimeter. The important lesson is that with this is that arc length formula can only be used when you're in radian mode. So you cannot key that 70 in. So we have to convert the 70 degrees into rads. And because the question is asking for a decimal version of it, you might as well put it you might as well decimalize it. So 70 degrees times pi over 180, I know you could simplify and reduce, and many of you will, and that's fine, but I'm going to cheat, and I'm going to go 70 times pi divided by 180, and I get 1.23 decimals, I get 1.222. So I'm actually keeping an extra decimal around, actually 2 extra decimals, which is a little unnecessary. Now we go into the arc length formula. A is equal to r theta. So 4.2 times 1.222, so the radius goes in and the measure of the angle in rads, and when you round that you'll get 5.1 centimeters. So that would be the arc length. So there's very important, make sure you do not use that 70 degrees without the conversion. So that's the method. And the next, we'll gradually, lesson by lesson, be getting into more complex questions. but we'll be using many of the same tools over and over. So it's very important that you get competent with these last two exercises. Thank you for your time.